Okay.
It's time for the next presentation. Stéphane Carré.
Yeah.
Will present us some data-related work that is in a slightly different area, web services. So we're pleased to hear that data is not only for real-time systems and for embedded systems and for safety critical and whatever, but also for other important applications.
So just a bit of history for me. I'm doing some open source development during the last 20 years. I've done a lot of work on GCC a long time ago, and during the last 7 years I'm doing a lot of work on Ada, mostly interested in web application. So today I will present REST API and OpenAPI standard, and I will show you how OpenAPI and Swagger can help in creating a web application, REST application. I will briefly introduce OpenAPI and Swagger, then I will describe how to create REST client, ADA client, then how we can write a REST ADA server, and how we can handle security with OAuth, and hopefully I will try to make a demo if it works. A little bit of background about RPC, 30 years of RPC. It's not new. I put a number of some interesting RPC mechanisms that have been used. Sun RPC is an old RPC mechanism which was introduced for NFS. It used a description file which was close to the C language, and from this description language we described how the client and the server interact. You describe the protocol and operations, and from that you generate some client and server stub. In 1991 there was a standard with Corba and IDL with interface definition language. And again, in IDL, you describe the interaction between the client and the server, and from this high-level description, you generate client and server code. Ada 95 has a distributed annex, so it was standardized a long time ago, and you had nothing to do except declare some pragma to make your operation remotable. But it was ADA-centric. Java on its side with RMI did the same in 2000, but again it's Java-centric. Around the 2000 we saw the emergence of WSDL with the SOAP protocol. All of the above, Sun, Corba, Ada and Java RMI use more or less binary protocols, which is difficult to debug. For when you have to understand the interaction on the wire, it's difficult. So people tend to say it's easier with XML, and they created SOAP and XML for that. And so the WSDL describes the interaction between the client and server, and from this WSDL you generate some code. Also recently you have Google, which has, with the gRPC mechanism and protocol buffers, they are pushing their RPC mechanism, and they have their own language. So what we see is during these 30 years we have the same goal, which is we want to simplify the developer job, first thing. We want to describe the protocol between the client and the server, and we want to have the code between the client and server which is generated. We want to also hide the communication details so that the programmer just have to call a function and that's it. Last is the documentation. Documenting the interaction, documenting how you can call your server with your API is also important. So why REST and OpenAPI? REST has came also since 2000. it was first mentioned by in the thesis of Thomas Fielding it was a simplification. It was easier to use. It was an organization of URI to be able to make requests easily, more easily than SOAP, which came at the same time. The good thing with REST is that you can use it from your browser natively, because it uses a standard HTTP GET POST PUT operations. And what we see is also an increased usage of REST API with all the mobile applications. If you Google, Facebook, they all provide API, REST API, because they would like to have more mobile application developed with their own API. With all of this, we need to have documentation. We need to document our API, and you need also a language binding. So each time you create your own API, you will have to write a Java binding, a C binding, a JavaScript binding, and so on. So it's complex. And here, OpenAPI and Swagger is a solution. So this came as an emergence of a company which created Swagger, and which then created the OpenAPI specification in 2010. And they made a consortium with Google, Microsoft, and a few others to standardize the way we are going to describe a REST API. They published their first, in fact, the third version of OpenAPI recently, last year, and the specification is available on GitHub. So here I'm focusing on version 2 of the OpenAPI, which, because most of the tools that I will use this version. The version 3 is not yet ready. So what is an OpenAPI document? This is just a YAML or JSON file which contains well-defined tags. So here I have defined the well-defined tags. Info is a tag which you describe generally what your API is doing. You have a description of the security with security and security definition elements. You define host, base space, and scheme, which tells you what is the entry point of your server, what is the host name, whether you can reach it with HTTP or HTTPS. You describe what your server produces, what it consumes, whether it generates JSON, whether it generates XML, whether it generates binary, whether it consumes JSON, XML, or forms. And then one important part is the path. The path, in the path part, you will describe each operation in terms of URL path and in terms of operation, put, post, delete. So this is really HTTP-centric, REST-centric. Then you have tags and external docs, which is some additional documentation which come and which brings some semantics to your API. You also have a description of data types, parameters, and response. All of them are used in the path. I will show you a little bit. So from this description, what you can do first is that you generate. Could we have yeah? If you have. Non, c'est juste ça.
Ah, le pointeur.
Juste le pointeur. Ok, merci. Okay, so first you can generate static documentation from the Swagger file. You can also have online documentation. The online documentation is interesting because within the online you can also make some queries and use your API. So it's an interactive documentation which allows you to play with the API. You can also generate the client binding so that you can immediately use the API. And you also generate the server part so that on the server side you have less code to implement. Swagger also allows you to generate Apache configuration and also provide support to generate automatically some validate automatically your API. So Swagger, we have a collection of tools, in fact, an editor which allows you to edit. Yes?
You say validate API. Do you validate the server implementation or validate the API specification?
Validate the server by injecting patterns and doing validation of your server.
Okay.
So the editor allows you to edit your OpenAPI specification, and the editor will tell you a lot of things about mistakes that you could do. You have the generator, which takes the file, the OpenAPI file, and generates the code for you. The Swagger UI, which is a dynamic UI that you can include in your web server so that you publish your API online. And everything is documented on everything is published on GitHub. So this is a Swagger IO editor. So here on this part you edit your text. On this part it shows you the documentation and including the errors. So the generator, what it does is it takes your document and it is able to produce around 25 different languages, including static documentation, REST ADA client, the Java client, Python, and so on. On the server side, it is also able to generate ADA, Java with several frameworks, with Spring and others, and Python and others. So I will briefly describe what is the process now to write a client with this model. The first thing that you will do to write a client is you will get an OpenAPI specification. Either by going to Swagger Hub, they publish a lot of OpenAPI that you can pick and use, or you can look at API Gurus, which is a repository which also publishes. Today there are more than 500 API from Google, Facebook, Twitter, and others. These documents are available. You can pick them. You can generate the ADA client code with that, and then what you just have to do is use the generated code. Okay, so I will describe here briefly the OpenAPI file. So, as I said, this is YAML or JSON file. In this example, this is YAML. So you have specific tags. This is the tag that I spoke about, info, host. This is the primary tag. And here you will describe your API in terms of this is some general information. Here you have what is the server that will respond to this API, what is the base path, a number of tags. Here you can access it with HTTPS and HTTP, and so on. So this is general purpose description. Here we have really the interesting part. So here you really describe within this one operation. In this operation, what it tells is that my API is accessed by going to /todos. There is also the base part, and the operation is HTTP GET. Okay. Here I have a description of my API, this is pure documentation. Here, this API produces a JSON, and it accepts as parameter an optional parameter. Required is not true. The parameter is, as a name, it's a status. This parameter is passed in the query. You can specify query, a form, or others. You specify the type of this parameter, and here you also describe the fact that this string is in fact an enum which can have only one of these 4 values. Then you describe the response, and in the response you describe the schema, what is really returned by your API. And here this is in a definition that I will present a little bit later. Here you have the status, the possible response code that the API can return. So you do this for each API, each operation that you have. Here I have the description that is returned by my get operation. So you have some kind of syntax where you describe a record. So this is a record composed of ID, title, create date, done date, status, and so on. Each of them has a types, a description. So there are a number of predefined types in Swagger, which has standard types. You cannot introduce new types, so there are some limitations. And you describe whether a parameter, a type, is optional or not. I will describe it later. So here, what we have to do, you have your Swagger file. You just use the Swagger Codegen to generate the client part. And what you get is this set of files. So your input is this file, todo.yaml, and it generates all of this. Separated in client and model, you have, on the model part, you have the data types which describe the response or inputs of your data model. And on this part, on the client part, you have all the operations that allows you to invoke, to call your operation. In these 4 files, you don't modify them. They are generated automatically. Your code is then in this part, which you can change. So, and this is just a sample program which shows you how to start and call the API. So, in terms of when your client is running, what component it is using, your application is at this level. You have generated this part, which takes care of the interaction with the server, which takes care of the data which is passed between the client and the server. We have a small runtime, which is using a number of libraries. So ADA Security is a library that I've created to bring the support with OAuth. ADA Utility Library is a collection of support that I've written to do JSON and XML serialization. It is also doing some HTTP abstraction on top of curl and AWS. So you have to you can choose either you use curl or either you use AWS, but this is transparent at this level. So the models package contains the type that I've described in the definition. In the YAML file, you have a description of what is returned in the response, and from this description, we generate ADA record. So the name is the name of the type is taken from the name which is here, and each member comes from a definition that you see here. There are some parameters which are optional. Typically, I spoke. There was a required parameter which says ID, title, create date and status are required in the to-do definition. But the down date is a parameter which is optional. So it has, in fact, another value. In Java language, you can use a null to represent the fact that there is nothing. In IDA, we have no concept of I have a null. So you have to use a specific type, which is here a nullable date. We could have a nullable string, which says there is nothing. It's optional. So in fact, this is just a Boolean and the value. We also generate a vector, which is used to manage a collection of to-do types. Just as a recall. Here I'm saying I have a type. This is my to-do type, but my operation is returning an array. So it is returning an array of to-do types. And to implement this is the ADA containers vectors, which is used for the implementation. So now, for the client API, it is represented by the client type. So we have this type, which is a tag type, which is generated, and it provides each operation that was described in the YAML description. So here we have a create to do, list to do. The name was part of the description, and then you have, of course, the client instance and all the parameters or response of your API call. Now, to use your this API, it's very simple. You just have to declare an instance of the client type, set up the server where you want to connect to, and then do the operation. So here, with these two instructions, you retrieve a list of to-dos. In fact, the list in this. Okay, let's see now on the server side. It's a little bit more complex, in fact, because on the server side, you really have, the first thing is that you have to write yourself the YAML and OpenAPI description. Then you have to generate the code and then implement what is behind your server. And then what you can do is also share your OpenAPI to a Swagger hub so that you share it with others. So on the server side, when the command to generate is this one, so it's very simple. You just have to change the generator. So it generates a number of files. So the server is very close to the client model. So here, client and server will share the same data model. And on its side, the server specific files. Here you have some skeleton, and the skeleton, in fact, contains all the extraction, all the work to extract the parameter from the request and call the server instance and respond with to the client. And here you have some files that you can modify and which contains the implementation of your server. Of course, it is empty.
Stefan, what happens then if you do this, implement the server, and then figure out, well, I have to make some change to the API, and you rerun the generator?
Yes. So Swagger Codegen, Swagger, en fait, has Swagger. I don't remember exactly the name. It has like a GitHub with a git ignore. It has a Swagger ignore file where you insert in that file the name of your file. So, for example, it's true that if you run this command several times, it generates everything. But if you decide to edit this file, you will add this path and this path to the Swagger ignore file, and then the generator will not overwrite your own file.
But then you have to adapt it yourself.
But yes, you have to adapt yourself.
So how much code would you, where would you go in to adapt, and how much code would you have to
I will.
on the generator?
In general, you don't have to modify. You don't have to modify this part and this part, and the part that you have to modify on this side is in general very light. I will show you. So on the server side, we also have a Swagger runtime here, which is using almost the same component with a new one, which is the ADA servlet, which is a way to the ADA servlet, in fact, is an ADA implementation of Java servlet that I have done some time ago, and this is a part that brings REST support for all the system. So it's run on top of AWS. Here you have the generated code, and what you just have to do is at the top. So the skeleton. The skeleton, in fact, it generates a server type limited interface with one procedure for each operation that is defined in your OpenAPI file. And in this operation, what you get is, you have your server instance, you have the parameter, input parameters, and what your operation, what your server has to produce. You also have a context parameter which gives you information about the request and the response, so that you are able to do some more control about it. So what you have to do, in fact, is just implement this server type interface. So it's very simple. Implement all the operations which has declared by that interface, and all the serialization and deserialization, everything related to JSON, XML, and so on. This is handled by the skeleton, so you don't have to do it. The last part is the server model. There are two server models. One model which is we create one server instance per request. This is a simple model. And another model where you create, where your server instance is shared among all requests. So you have to choose between the two models. When you choose this shared instance, you have a single instance of your server, and it is protected by a protected object, so that if we have concurrent operation, we are safe. So you just have to instantiate the skeleton generic package, and then you have to register this package to the application. And then when the server is started, it will be able to serve the requests which are defined. A word about security. So in the security, you will describe the security within the Swagger document in two parts. First, this is a general description of what security you expect. So here this is OAuth security. In the security part, you will describe the scopes. So here, the scopes are related to permissions. So you allow writing to-dos and reading to-dos. And then on the API part, you will specify what is the scope which are required for the caller to make this operation. On the client side, if we want to use OAuth, you will create a credential object, and this credential object will hold the OAuth information. OAuth contains a number of pieces. I will not describe OAuth completely because it's really complex. So you will set an application identifier and an application secret. So this identifies the application from the server point of view. You will describe the OAuth access point, and then with this call, you will authenticate to the server with your username, password, and asking to the server, this application, I want read to do and write to do scope. So I want these two permissions. And when you have, once you are authentified, you obtain a token, and you just have to set your client credentials, and you are done. So now when you will make a call like this, in fact what will happen is the authentication will be passed in this authorization header in the bearer token, which is here. So this is RFC 6749 for those who want to look. And this is what grants you access to the API. Now, on the server side, what we have is each scope, in fact, generates an insertion and a definition of a read-to-do permission, which is in fact the instantiation of this package. So this creates a definition of the read-to-do permission. And then the generated code, what it does, it uses the context to verify that we are authenticated. If we are not, it rejects the request with a not authenticated error. And then it verifies with the context whether the client, the application, has the given permission. The last part is more configuration. You have to register the application which are allowed to connect. So that means the server has to know the client ID of and the client secret of applications, so that it can verify that these applications are allowed to are granted the access. And you also have to configure the possible usernames, user and password. So this is I would say some kind of toy. You can do it programmatically, but for the presentation it was a little bit complex. Okay, so I can do the demo. I'm not sure.
Good luck.
Yeah, thank you.
Keep on praying.
You're lucky. So I will probably do. I don't see anything on my laptop, so it's not really easy. Okay. No, it's okay. I'm not going to make it. Okay, so I will make it differently. So here I have my to-do example where I have, it's a final example. Sorry, it's a complete example with a working client and a working server. So in this part I have the generated code on the client side. So here you see the operation that I have created, create to do, delete to do. So these are the operations which are defined in my OpenAPI file. Just to show you the implementation of create to do, what it does is it serializes the parameters and it makes the HTTP, the post call, and it deserializes the results. So it's very simple. I will show you the client. So here I have an example. So I have my instance of the client. I configure the credential of this client, and then here at this line I'm calling the create to-do with my title, and I obtain a to-do object which is at this level, and with this my to-do is created. Here you have an example of getting a list of to-do. You obtain a list, and then you can easily iterate over this list. Okay, on the server side, what you have to implement is very simple. I will start from that. So here I am defining my server type instance. So it implements the server type skeleton that I have presented. I have used the shared instance so that I'm holding all the tasks in the object which is here. And what I just have to do is populate the information, return it, and insert it in my object. So the code that you have to write is really simple on this side. For deleting a to-do is also the same. And just to show you the skeleton. So the skeleton does the same. It extracts parameters before calling your implementation, and then it serializes the results before returning. Okay, so I cannot show you. It's too complex for me to. Et je suis perdu. Ok. Limitation and improvement and possible improvements for the future. Added strings was a problem for this. Why? Because we have many types of strings. We have wide string, wide strings, unbounded strings, unbounded wide string, unbounded wide string, bounded strings, bounded wide string, bounded wide strings. Do we have more? I don't know. So it's nice to have. Yes?
It's all for the moment.
Okay. It's nice, but each time you have to pass a string, at some point you have to do a conversion. I made the choice to use unbounded string for every parameter, which means that when you have an operation which gets a string as parameter, you have to convert it to an unbounded string. So it means that you come up to a lot of two strings or two a string conversion to do from one type of the other. Enums are treated as strings. It's not really good. We don't benefit of all the benefit of having a real enum. The problem is that in YAML, every operation can define its own enum, which means that we would generate one type for each enum definition, and we would end up in other problems, like having a lot of enum definitions which almost say the same thing, and you will have to convert between them. Circular dependencies is also difficult. In Java, you can have circular dependencies in the definition of YAML, and you can pass a graph of objects. In Ada, the representation of a circular dependency is a little bit complex. You can do it with scope pointers, but then you will have to free the memory. Who owns what? It's not easy. The error model needs some improvement. When you have a 404 error which is returned by the server, we can raise an exception, but when you raise an exception, you lose some information about the API call that you are doing. So sometimes it's not easy to always manage errors with just exceptions. Some possible improvements. There is no support for files. Uploading a file is not yet supported, and asynchronous operations are possible. Some client generators support asynchronous calls. This is just a matter of implementing this. So OpenAPI describe your REST API, and Swagger generates the code for you. It's really easy. You can publish your API. You can use API published by others. Just do it. GraphQL, this is another way to make requests to a server. GraphQL was introduced by Facebook 2 or 3 years ago. This is another challenge because, but it's another interesting challenge. You describe elements of data that you want to retrieve. You push some kind of graph query to the server, and then the server reply. This could be a next challenge. Thank you.
Any questions? Yeah. So what you describe is a lot like SOAP, and
yes.
what AWS is doing for SOAP. So two things. One, in AWS you are able to generate the description file from a data specification.
Yes. Yeah.
Is it available? You plan to make it?
Is it available? No. In fact, the tool I'm using is a tool implemented in Java by a community which is not ADA-centric. This is a community which is oriented PHP, Python, JavaScript, and they focus on really starting from the OpenAPI specification, and then from that generating code from different languages. They don't do the reverse.
Yes, but you can get in touch with Pascal Away and ask him to adapt his tool to generate
yes.
REST rather than...
I've looked into this problem of custom recently, and although we for SOAP actually used data specifications we used data packages as a source code or some SOAP services. But when we looked into OpenAPI, what we saw was that we actually had better ability to document an interface with OpenAPI than with data package specifications. So we decided to go with OpenAPI and then a custom, unfortunately still proprietary implementation similar to what Stefan has presented, but using the OpenAPI specification files as a reference to generating the data from that.
In fact, my question was, how is it better than SOAP?
It's different. In SOAP, in fact, if you want to do a SOAP query, you have to create a XML document in which you describe the parameter, in which you describe the operation that you want to call, and then you will use a post, only a post HTTP command to invoke your request.
It's all generated automatically.
Yes. REST is really easier to use in general because you will just do a get of a page, put of the same page, delete of the same page. In fact, you use the HTTP keyword to express the operation that you want to do. Getting, updating, deleting, creating. When you create an object, you post some content on a path. When you want to delete an object, you delete a path. When you want to update an object, you update a path. So it brings something which is easier to use, which is in fact easier to construct, because you just have a path to construct instead of a complete XML document that you have to write to express, I want to call this operation, I want to pass this parameter and this parameter. Have your XML document that you subscribe to the server.
My question was, with all these APIs on Swagger Hub and OpenAPI websites, do these publish their own RESTful APIs that we could just call Swagger Era on all of these and get all the libraries at once? Integrate all the data from all these descriptions just using their own API?
I'm not sure I understand you.
Swagger API, the website which collects the APIs for all the services, do they allow easily to collect all these APIs?
They publish, they allow you to publish your API. They allow,
but to collect them for us, for example, to generate all the code that corresponds to...
Yes, you can.
Yeah,
yes, you can. Yes, you can. Yes, you can. Yes. Yeah.
To ask a question, I have a remark. The ADA code generator,
yes.
Swagger Codegen,
yes.
you contributed it to the official
yes.
repository. Now it's part of.
Yes, the ADA code generator is fully integrated in the official Swagger distribution. William Chen is the official maintainer, and each time we fix something, he integrated immediately the fix. So he's really proactive at integrating fixes and improvement in his core project.
Congratulations.
Thank you.
That's it. Thank you.